Hello, my name is Craig Jackson, and thanks for joining me. I've been watching NixOS as an observer for a while now, and over the last couple of years, there has been a lot of movement in the CI, CD, and build spaces of NixOS, Nix Anywhere, dev environments, even micro VMs. And then AI happened. And with AI, I really think that all of the inherent barriers that kept NixOS from being used and was a nervous choice in the past, I think it's finally eroded away, and the time is now to start using Nix. And it's gaining ground out on the network edge where I work in monitoring, alerting, build runners, and infrastructure testing scripts. But first, the obligatory who am I? Well, my name is Craig, and I'm a redneck adventurer when I'm not working, climbing mountains in these off-road machines. I'm a synthesizer enthusiast. I like to turn buttons and turn knobs and push buttons. But process and automation has always been a part of my life. I studied horticulture in college, where you automate the life of a plant. I worked in healthcare as an orthopedic surgical consultant, where I worked with surgeons and hospital systems to increase efficiency and minimize waste. COVID let me leave that industry, and I'm happy to return home to the internet because I found IRC in my teens, and I've never left, and the internet is home. So I finally came back to IT, and now I'm a DevOps engineer at a company called NetActuate. And we are a global infrastructure cloud provider with a network-first focus. So we have a managed Anycast network that our customers use for low latency connectivity to their end user. We even hold the HRoot DNS server on our network as the low latency connectivity, and Anycast is kind of our bread and butter. And so what we're going to talk about today is the importance of the edge network, how significant it can be in both cost and management requirements, the difficulties in setting up that infrastructure, and then we're going to explore how NixOS adoption is being increased out there on the edge in these single-use cattle-type machines. And we're going to end it with trusting in NixOS, but I'm at a NixOS conference, and the talks yesterday and today are more about how to give the messaging to other people and recruit other people to our cause. And so I'm going to modify the trust at the end a little bit, because I believe that Ron and Kelsey had the message correct yesterday. But to get back to the network edge, I'm going to use a few terms, one of which being POP. I'm going to say that a lot. That's just a point of presence where we announce your service across the globe to bring your end user into it. But the network edge are multiple POPs kind of loosely fabriced together to create multiple entry points into your service around the globe. It's important to maintain an edge network and to build it for multiple reasons. The closer you can keep the assets to the customer, the less bandwidth charges you'll incur over time. As you increase regions and your service grows, you can rapidly scale with a new POP. And it can also give you data sovereignty compliance. And that's becoming very important as the geopolitical system falls apart. And so more and more countries and more regions want you to keep their civilians and their citizens' data in the country that they live in. And ultimately, when you do have a resilient and reliable edge network, your customers and you enjoy low latency connectivity. And so what type of infrastructure and what type of workloads makes up an edge network? Well, again, we're bringing people into your network and into your service. And these machines are typically single-use machines, and so they're quite perfect for Nix, in my opinion. Such roles would be like a BGP ingress daemon or a reverse proxy into a Kubernetes cluster, firewalls, load balancers, etc., depending on the service that you're providing and the needs of that service at the edge. And there's a whole lot of different ways to instill this infrastructure on the edge. We have all the infrastructure as code tools. We need to manage multiple data centers, so there's infrastructure management tools. There's networking appliances that we need to connect together in all of those different locations. And all of that's loosely tied together with Git runners and webhooks and everything else And once you have that infrastructure, we need to alert, we need to monitor, and we need to observe. So there's a whole lot of infrastructure that surrounds your service on the edge. All of it's important, and all of it can be dangerous to maintain over time. And so these challenges present itself in multiple ways. And the Nix answer that we already know is really the configuration drift. We need to be able to trust what we're doing, and we need to be able to rely on it consistently over time. And on the edge, since you're not in control of the data centers, the locations, and you're not in control of the hardware and who's going to be working on it, it's just timely to maintain, it's expensive to maintain, and when these systems start to fail, you can no longer trust the infrastructure on the edge of your network. And all of this leads to increased costs over time. Not only in managing the infrastructure itself, but the configuration spread out over 2 or 3 different systems. You've got Terraform and Ansible, and when you're using multiple points of presence, you really would benefit from having NetBox and AWX. So now we've just increased our amount of infrastructure that we need. There's also time spent managing all of those. And since it is scattered and we have all of these little pieces of data that's all over the place, who's forgotten to update the CI/CD vars and pushed run? Who didn't notice the GitHub runner didn't finish yesterday? We run into those problems. And the Eureka moment with Nix came for me when we enabled the ability on our platform for customers to install Ubuntu. They can go in and customize it. They can edit their SSH keys. They can add their ingress rules. They can give the basic bootstrapping already set up in the machine. And then they can lock that machine down and clone it and deploy it in multiple regions already bootstrapped. And they loved it. They instantly started creating multiple packages, one for each region, and now we have so many private images, one for each region, one for each service. It's rapidly getting out of hand because we have 45 POPs, and if you maintain an image in every single POP, well, now we're looking at 207 gigabytes of storage just for your bootstrapping images. And so these managing the infrastructure on the edge gets costly, and it gets very hard to keep the configuration in a constant state. And so Nix was brought to me by a customer, and she was trying to figure out if she could run services that were single role systems with lengthy policy-based configurations. So caching systems, BGP ingress, firewall rules. You have to put them in order and they all relate to each other. And if you mess up that rule set, the system's broken and it doesn't work anymore. And so it's easy to roll back, it's quick to rebuild, and she wanted Nix out on the edge. So I confidently and arrogantly said, it's just Linux, of course I can get it to work on our system. And she said, great. And she sent me this. Well, I don't think KVM can deploy a Flake. I didn't know what to do with it, and this is why I didn't use it. This is why I didn't use it for years. Because I can do it quicker with Ubuntu at this point. I have to learn this first. And so this is where I'm gonna pivot a little bit and talk more about what Kelsey and Ron have been talking about. I trust in Nix now because I understand this enough to get it started. And I'm also not a tinkerer. I'm not one of you guys. I use it strategically like a scalpel to fix one singular little problem. I use that compute outside of my Kubernetes cluster. And so I don't think that trust sells to other people well, because they trust this. They trust this. And when I tell them that I don't trust this, they say, skill issue. I trust that. My Terraform works. Why do I need to learn a whole new system? Well, because this, as to Kelsey's argument yesterday, isn't consistent. It's non-converging. I have to go to 17 different systems to understand this. But what works for me is I can now begin to converge my configuration down to a base Flake. And the next customer that showed me how to use it effectively in a team opened up my world, and now we're using Nix internally. I'm no longer just watching customers use Nix. I gave this talk internally last week to our company so that I can practice and get their thoughts. The tech lead, so my role in the company is I get to prototype with our architect. And then when he's done building what I helped design, I then brute force what he built and try to promote that to the customers. Here's what we just made, and here's the cool shit you get to do with it. After I gave this talk, for the first time he said, do you think I can get our Kubernetes worker nodes for our managed Kubernetes service on Nix? And I said, do you think I can? Yeah, oh, do you think? And he said, well, I need consistent boot times now. We need a predictable deployment strategy, and we need a quick deployment for Kubernetes worker nodes. It's currently slow. And so now that it's consistent and it's quick to boot and it's faster than Ubuntu once it's programmed, he's in. I've got his buy-in, not because I trust it. He doesn't trust me. It's consistent. And it's when you have everything built in. And by the way, the only reason that he's going to use this is because I've built the configuration. He just needs to load his service into it. I built the Flake, so I've given him the dev shell that he needs to interact with the service that he's going to put on my infrastructure. And network.nix, this is ephemeral. We inject Cloud-init secrets into the machine, but we're not going to rewrite our ISO vendor data attachment because it works for every single of our other operating systems. And so Nix doesn't persist the network. That's the one caveat. But that's fine because you're going to rebuild it with your own system anyway. You can persist the network. And we automate that with a Cloud-init script. So inside Cloud-init, you customize your base Flake, and then you can download the role that Flake needs to inherit. We've now reduced entirely how many images we need. We need one. And we can download the ephemeral role and reboot it into that role anytime we need to. And so now we have a seamless build process, and we've got that comfort and trust. We can treat this like cattle or pets because it's truly reproducible, it's truly declarative, and it's truly software. And so if we look back at this role listing again, the first customer brought it to me with BGP and proxies. But that configuration is a pet, in my opinion, because we're going to continue to iterate on it. We're going to roll back, and we're going to nurture those. The top 5 or 6 all kind of feel like pets. The configuration is very similar. And so if it works for BGP, if it works for proxies, it's also going to work for all of these others. And so again, the cattle, I think we can replace GitHub runners. That's how I'm using it internally now. I am getting rid of GitHub runners entirely. They're going to charge me for my own time that I'm going to run my own runner? No. Also, they're going to give me shitty implementations of their runners for me to interact with. They lock, they freeze, I have to go in tomorrow and make sure they finished. I can do better with NixOS, and I can do it better with just webhooks out of GitHub, because they let you attach a secret to it. So now I have a listener of webhooks, and the secret is the role that I want to boot. And I just have a whole bunch. I'm an infrastructure cloud guy, and I hit every hammer or every nail with a VM. So I have a whole bunch of NixOS machines turned off, just waiting. And I have a listener that receives a secret and turns on that role. It does a cron job, and it turns itself off. And so I have a fleet of single-use, quick action, quick to boot, persistent, consistent machines, and it's just a fleet of runners. With that, I can use Kubernetes, jobs, and still have Kubernetes orchestrate my little GitHub runners. And so if it fails, Kubernetes fails, it runs it again. And so I can interact with my little running system and create a whole bunch of builds, and I can start to add in just little single-use pieces, all scattered throughout the infrastructure around my team, and they have buy-in because I've made it easy for them to interact with. And so in summary, the edge network is significant, and it's something that you should babysit, and it's something that if you manage correctly, your customers will enjoy, and you will enjoy as well. It is difficult to manage, and as your service grows, the complexity and the size of your edge network hopefully is going to grow as well. There were inherent problems not to use Nix, and that's what we're overcoming today. But those are gone. AI happened, and two things happened with that. All of our bosses are now comfortable with approving uncomfortable things. That's just the reality of it now. They're approving AI slop. And guess what can be part of AI slop? Use Nix. They don't know what's in the code. They don't know the infrastructure it lives on either, and they're rubber stamping it. Let's use Nix. Because in this, I'm using it because I trust it. I came from out of industry. I understand process and I understand automation. However, I missed containers. I came into the cloud after Docker. Kubernetes is an amazing machine to me that I finally understand enough to interact with it, and I love it. But there's inherent problems with all of this. I love running workloads in Kubernetes. I hate finding the workload that failed. And so in all of these abstract systems, I've lost that intimate touch with the data. I've lost the intimate touch with the infrastructure. I've lost the intimate touch of all of it. And I'm just observing it now. And the only thing that I can trust in all of this abstraction is a configuration or a flake.nix file, because it's all explicitly listed. And when you have it peppered around all of these abstract systems, it's like bumper cars in bowling. You pull out the little bumper and you keep this abstract system going down the middle of the lane. But if you don't have these rigid constraints built around all of these abstract systems, there's no comfort there. And so what's crazy to me is when I first looked at Nix, I saw chaos. And now I see order, because the rest of the systems around it are getting chaotic. And this is comforting. This is calm. And so in closing, again, my name is Craig Jackson. I work with a company called NetActuate. We do really get excited about infrastructure and cool, fun projects. So if you have a NixOS project, I can give you a base Flake. Come and talk to me, the Flocks and the PlanetNix crew. They've been incredibly helpful. So if you have any questions about where to use Nix, where to put it in your infrastructure, how to convince your boss, how to get buy-in on your team, please come find me or them, and we'd love to talk to you and help. Also watch our GitHub, because I'm using Nix now. And so I'm going to start creating a bunch of flakes and workflows that just make it easier to consume. There's not a good example of attaching vendor data in Cloud-init on a no-cloud ISO and have that data persist inside of a Nix flake. And so we're going to start creating examples as well, because we really enjoy this community and we're glad to be a part of it. Thank you so much.